Okay, hopefully this one will sound better than some of the other ones I've done before. This is Unit 7, and I've learned how to auto-adjust the levels on the microphone, so we'll see if it works. I'll also try not to look away so much, because I guess that's pretty bad when I do that. So I'm new to this, so please be nice. Okay, Chapter 7. It's also Unit 7. We're back on track, and it's about probability. Ding dong, the trig is dead. Okay, so we're talking about trying to find the probability of things. Hopefully you've done some of this before in some algebra course, but you know what? I really have no idea. So I'm going to kind of start from the beginning. The book talks about probability, and they use words like experiment and outcomes and sample space, and I don't know what of those you know already. Experiment and outcomes I don't really define here. An experiment is basically just anything we're going to do where there's a certain number of different possibilities that can come out, like flipping a coin, your outcomes are heads and tails. If the experiment is coin toss, outcome usually is heads and tails. If experiment is pick a card, then the outcomes are, well, you have to list all the cards, and there's usually 52 cards in a deck. If the experiment is roll 2 dice, then the outcomes are things like double ones or a 1 and a 2 and stuff like that. And then the sample space would then be that entire list of outcomes. So I did one here for you. It's the list of all the possible outcomes if you're going to toss 2 coins. The first one could be heads and the second one could be heads, or the first one could be heads and the second one could be tails, or the first one could be tails and the second one could be heads, or they could both be tails. Now the first question I have for you is, why do I list these two separately? How come these two aren't actually the same? Well, think about it this way. Think about the first coin. Let's pretend the first coin was a quarter and the second coin was a nickel. Then if I'm just going to toss these 2 coins, then this possibility, the quarter being heads and the nickel being tails, would look different than the quarter being tails and the nickel being heads. Because when we go to compute these probabilities, we want to count these things correctly. We want to make sure that we don't count things too many times, or we don't count them not enough times. The probability here of heads and tails is actually twice as likely than, say, something like both heads or both tails. This can happen, the fact that they don't match could happen kind of 2 different ways. It could be a heads on the quarter and a tails on the nickel, or a tails on the quarter and heads on the nickel. So then you're thinking, well, why does it matter if I'm talking about 2 quarters or a quarter and a nickel or something like that? Because if I had 2 coins that looked the same, the first one being a quarter and the second one being a quarter, then heads on a quarter and tails on a quarter looks just like tails on a quarter and heads on a quarter. So why are they actually different? My answer to you is, well, if you're going to count the probability of heads on one and tails on the other, the same as this one. Well, think about this for a second. If you got 2 heads, that's pretty rare thing happening, because there's only one way to get that. You'd have to have heads on the first one. You'd have to have heads on the second one. If we're talking about heads and then tails, or having one of each, basically, yeah, there is 2 ways that can happen. Because if you think about this, if one quarter comes up and it's got heads on it, and the other one comes up and it's got tails on it, think about the sides that aren't showing at this point. On the back of this coin, there's a tail, and on the back of this coin, there's a heads. And had that come up, there's essentially another possibility there that was just as equally likely as this one that could have come up with a tail and a head, but they would have been on opposite coins. Whereas if you have something like tails, tails, there's no other possibility sitting there on the back of the coin that could have come up the same way, like it is here. So that's sort of a long explanation for what you're supposed to say for question 1, which is why is it that I don't list this as 3 outcomes, matching with heads, matching with tails, or not matching? Why aren't those the three possible outcomes? Well, the answer is the first one could come out heads or tails, and the second one could come out heads or tails. And if I list all possible combinations of those, there you go. Or if you like the explanation about quarter and nickel, then here's the four explanations. I like that. Or if the coins were different color. Now, the fact that we've got coins of different color or coins of different denomination should not really change how many different outcomes there are. The dice thing is going to come up a lot. There's very popular examples that are going to keep coming back to dice. And they have this chart on page 427, but this is by far the best way to list this. It looks almost exactly the same here as it does in your book on 427. Just like we did with with the coins, if we're talking about the possibility of a 1 and a 1, of 2 double ones being rolled, That's one possibility. I don't really have to list that backwards because a 1 on one die and a 1 on the other one, that requires both of them to be 1, and there's only one way that can happen out. The only way that can turn out is one way. For there to be a 1 and a 2, well, and I kind of like how they have the two different colors here. The first one could be 1 and the second one could be 2, or the white one could be a 1 and the change my thing here. The white one could be 1 and the pink one could be 2, or the white one could have been 2 and the pink one could have been 1. So I do have to list those separately because that can happen two totally different ways. Of course, the probabilities are the same whether or not the dice are the same color or not. It's just when they're different colors, you can really keep track of which one's happening. So to compare these first three here, the possibility of getting a sum of 3, a 1 and a 2, is going to happen twice as often as if I require them both to be 1. And this is why. And so all the possibilities are listed here in this nice chart. And by listing them this way in the chart, or some similar organized way, a couple nice things happen. First of all, you could say, well, where are all the doubles? Well, the doubles show up along this diagonal. That's all the places where I have two matching things there. Okay, sorry, I need to get back to my pen. Oh, we lost everything. Let me fix that. Sorry. The other kind of nice thing about this is you could think about where are all the sums of the same. Sorry, all the possibilities have the same sum. Well, here's a possibility. If you had to roll a 2, here's the possibility you're going to roll a 2, and that's the only way you can roll a 2. Where are all the things in here that are going to show the possibility that you're going to roll a sum of 3? Well, a 3 could be here or here, and that's all the ways you can roll a 3. What about 4? Well, 4 could be this one, or this one, or this one. You see how these are lining up on diagonals? And the 5s, I've only got 4 colors here, so I'm going to stick with 4 colors. Oh, maybe I have more. That's just a waste of time. Sum of 5 could be here, or here, or here, or here. Sum of 6, you notice is going to be like this diagonal. Here's all the places to get 6. So it's really easy to count these, and that pattern continues. Because you're going to notice that one of the first questions they're going to ask is, what's the most probable sum? You notice along this diagonal, this is going to be the longest diagonal in this little rectangular arrangement, and that's where they all add up to 7. Okay, so this is all the possibilities you can have of rolling 2 dice. And notice that there are 36 of them. That's going to come up a lot in the unit. All right, next topic. Oh yeah, so some of the sample spaces are infinite. Like if you're trying to talk about what's the probability that you land in a certain spot on the dartboard, or what's the probability that your random number generator's in a certain range or something like that, or what's the probability that some randomly select person is a certain height or within a certain height range. And you get these infinite sets of possibilities. You can't list them all, but we still have things we call the sample space and maybe a range of possibilities. And what we're going to talk about is a favorable outcome versus a total outcome. Okay, so speaking of random number generator, okay, so on your calculator, you see that there is a random number generator, and this is how you find it. It's kind of nice for if you want to program your calculator to run a game simulation or something like that, or any kind of random probability simulation. Oh, there's also probability simulations in the apps. I will talk about that too. And I think all the ones in the apps are based on this random number generator, which has its problems. Okay, you go into the math menu. You want to say, give me a random number between 0 and 1. That's how random number generators are set up. And in the probability menu here, which you can get to by going left. Notice I go on the left. Oh, and by the way, if you ever see me use this, here's the key press history. You can see what I did. So I hit math, and I went left, and I get this menu. And the top thing there is called rand. Notice these other things we're going to be using. This is the probability menu after all. Probability is what this unit is called, so a lot of these are going to show up. All right, so probability, first thing is called rand, and if I just hit enter, I get rand on my screen. I hit enter, and it's going to tell me some random number between 0 and 1. And it picks, a really specific number between 0 and 1. And I can do whatever I want with that. In the middle of a probability simulation, that's kind of nice. It will pick a random number at any point. If I hit enter again, it's going to give me another random number. And I can keep doing that, and it's going to keep giving me different random numbers. Now, if you do this on your calculator, you're not going to see these exact numbers. Your first random number will probably not be 0.043991, etc. Your first random number, I think because of a fault in the calculator software, that these numbers aren't truly random, that they are actually stored in some crazy list. So I'm going to ask each one of you to come up with a different random number and see if it's really different, or if anybody actually gets some of the same things here. There's some computer theorists out there that believe that there's no real thing as an actually random number generator. So I ask you to do that here in questions 2 and 3. So first of all, in question 2, find your random number. Use the random number generator and just count how many letters are in your first name, and that's how many times I want you to hit enter here, and then say what the random number is, because hopefully that will mean that different people get different answers. We'll check that when we come back to class. And then why did I ask you to do that? I think, and check me if I'm wrong here, but I think if everybody just went random for the first time the calculator was new, we'd all get the same one. Now, I can't do that on this calculator because it's not new anymore. So, you know, this is maybe the 50th time someone has asked on this calculator simulation here for a random number, and I think that would be everyone's 50th one. And look how high that is, 0.995. That's really high. So we should test and see if anybody comes back and has the same number of random numbers. Also, I want you to do it enough so that we're all in different places on the calculator history, and you have different. We really do start getting random numbers. Oh, while I'm at it, I'll show you this cool random. This cool probability simulation you have in here. If you go into apps and you go down into, I think I can just go alpha P. Where's P? It's 8. I get down into here. There's this thing called probability simulator. If I'm on the probability, oh, notice this little 3 here means I hit down 3 times. Okay. You might not be able to do this alpha P jump thing. You might just have to scroll down. You may have a different number of things in your applications menu anyway. Anyway, I think everybody has probability simulator. If I hit enter, I go into this cool thing. Looks like a game. And it kind of is a game. Let's do the, we were just talking about dice, weren't we? So let's do dice. I can roll the dice here. I'm getting the dice experiment. Right now it's set up for rolling 1 die, and the possibilities would be 1 through 6. And if I just hit this, notice this button goes with this in the menu. I just tossed a dice and it was a 5. You notice it has this little menu down here. This corresponds to these 5 menu buttons. If I want to roll it one more time, I just hit that again. And here comes the die again, and I got a 1. So it's recording here. I got a 5, and then I got a 1. If I want to roll it 10 more times, I just hit this one, and it only shows me 1 animation here. But it goes through 10 more rolls. Notice there was a 12 there, because now I have a total of 12 rolls. And it's showing me sort of the different popularities of these different rolls. It looks like I've rolled 1s and 5s a lot, but I've rolled them all a little bit. I've rolled 3s more than I've rolled 2s. You can also go plus 50, and it automatically does 50 more. And it kind of tells you, and it's just sort of a random game here. It just kind of tells you what the relative, it's called relative frequency, which we're going to get to in this very section. What's the relative frequency of all these different rolls? And it looks like, for whatever reason, I'm not rolling very many 6s, but I've only rolled the thing like 60 times. So far, I've rolled a whole bunch more 3s than I have 6s. If you want to see the data, it'll actually show you this too. Like, it'll tell me, oh, that's not the right thing, sorry. I think it's table. Yeah, if I go to table, it'll show me what the actual rolls are, and I can scroll up through that. The 62nd roll was a 2. Of course, the sum of the 2 is 2. It's just the sum of all the dice. But if you want to, you can change. We'll get into this when it becomes more appropriate. But you can get into there, and you could change how many dice you roll, whether or not the dice are fair, and of course there's other experiments too, like marbles and spinning a spinner and drawing cards and generating random numbers. Anyway, that's just a little calculator fun that we're not going to quite get into yet, but it's cool to see. Okay, so back to actual probability questions. This is how it works, and hopefully you've seen this before, that a probability answer is something between 0 and 1. It's going to end up being this fraction, kind of like sine and cosine and tangent, but totally different. A fraction where we calculate the number of ways something can happen favorably. Like if I want to know the probability that I'm going to toss 2 heads in a 2-coin toss, this would be the number of ways that can actually come out favorably, that meets my requirement, out of the total number of ways it could have happened favorably or unfavorably, like the total number of cards in the deck, or the total number of possibilities in rolling 2 dice. So it's like, how many ways can it happen that you want it to happen that match up with this E here, out of the total number of ways it could ever happen at all. All right, so back to that first experiment about the coins. If you're going to toss 2 coins, there's 4 possibilities. What's the probability here in number 4? What's the probability that you get at least 1 head? Let me just write this here. We could have heads, heads. We could have heads, tails. We could have tails, heads. Or we could have tails, tails. There are a total of 4 different possibilities total. So this probability is going to be a fraction. The probability of at least 1 heads is a fraction. It's a fraction out of 4. Fraction is, on the bottom of these probability fractions is the total number of ways that tossing 2 coins can even turn out. And then the at least 1 heads is what I put up here for favorable. So how many of these have at least 1 heads? Well, that one has at least 1 heads, that one has at least 1 heads, and that one has at least 1 heads. So there you go.